Okay, now we got the law of thermodynamics, which states the amount of the heat loss is same as amount of the heat gain, because energy cannot be created nor destroyed. The amount of the heat that was lost by the gas was 56.5 megajoules per hour. So we're going to do the same. We need to find out the amount of the heat gained per hour. So now the amount of the heat gain is actually heat gained by the water. So m dot, actually if I do the one more step, amount of the heat lost by the gas, so it's going to be Q gas should be equals to the Q water, because I'm doing per hour, so I'm going to put the dots on the top. We have this value already. Now we need to do the value for this one. This is same formula, mCp delta T, and I need to find out the delta T value. The value for the lost heat was 5 point, it's from the previous one, 56.5, sorry, 56.5 times 10 to the 6. Now remember, this is per hour. This is per hour because this is a mass flow rate per hour. Now that's the value I got. Now on this one I need to find the delta T. So if I rearrange the formula, this is delta T. These two things are being multiplied, so I can bring it on the other side, and I'm just going to divide this value. Yeah, on these two are multiplying, other side divide, and they will give me delta T. Let's put the values. So I got the 56.5 times 10 to the 6, and the value for the mass flow rate for the water was 1400 kilograms. Multiply by the Cp for the water, they say take the value 4190. So I'm just taking the value, and then I will put that in calculator to get an answer. When I put in these values in the calculator, the change in the temperature, the value I got is 9.6. Now this is change in temperature. It can be in centigrade, it can be in Kelvin. Now the temperature for the first one, temperature for the I was 10 degree C. So the T2 temperature is going to be 10 plus 9.6 degree, and that's going to be 19.6 degree. Now this is in centigrade. If you want to convert into Kelvin, just add 273 into that one, and you will get around 292 Kelvin. For the parallel flow, the cold fluid enters at 10 degrees centigrade. The hot fluid enters at 350 degrees centigrade. It leaves at 100 degrees centigrade. The mass flow rate of the cold fluid is 200. Hot fluid is 200. The mass flow for the cold fluid is 1400 kilograms per hour. Now for the pipe diameter, for the hot is given as 75 millimeter. Now we got this formula, Q dot equals to UA delta T naught minus delta Ti, the outlet, change in temperature at the outlet, minus change in temperature at the inlet, divided by ln of the change in temperature of the outlet divided by the change in temperature at the inlet, where U is the coefficient, the total coefficient. We have the value. A is the area of the cylinder. We will have a formula, pi RL. Pi RL is the surface area of the cylinder. Two sides are open. And Q is the heat transfer per second, Q dot. Okay, now let's have a look at that one. We have the formula here. The temperature of the hot at inlet minus temperature of the cold at inlet, that will be delta T1, which is that value, delta T1. Now, the temperature of the hot at inlet, the gas was going in at 350 degree and the water was going in at 10 degree. So that's going to be 340. Does not matter Kelvin or centigrade, the difference is 340. Outlets, the gas comes out from the outlet at 100 degree, and the water, which at the inlet was 10, but it comes out from the outlet was 19.6. So 100 minus 19.6 is 80.4. So we got that value. Now, what we're going to do is, because we are trying to find out the length. For the length, what we're going to do is we are going to actually find the A, rearrange the formula for the A. So when I rearrange the formula for the A, everything from here will go on the other side. So you have a Q multiplied by ln of the delta T naught over delta T1 divided by U, and then in bracket delta T naught minus delta Ti. So I will have this value and that will give me area. I need to find the area first. Okay, let's put in the value. We have the value for the Q, which is 56.5 times 10 to the 6 multiplied by, I put the dot in multiplication, ln of the two values. So T naught is 80.4, and the other is 340. Divide by the U. The value for the U we got from the start, 0.25, and that one is 80.4 minus that value, which is 340. One thing I miss is this was per hour. So if it's per hour, I want to do per second because everything has to be in the standard. I need to divide that thing by another 3600 to convert 1 hour into seconds. And this will give me the value for the area, which is 348.7 meter square. That's the value for the area I got. Now the surface area of the cylinder has a formula. This is a cylinder that's closed cylinder. It's 2 pi r square plus pi r L, where L is the length of the cylinder. This is the cylinder that's kind of closed, like I need to find that and that, which is pi r square, hence I got 2 pi r. And the area of the curved surface, which is the middle one, is pi r L. Now in the heat exchanger, that side and that side, we don't need that surface area, which means I need to get rid of the pi r square. I need to get rid of that one, and the area, surface area, is only going to be this formula, because this side and this side, they are open, so I don't need to. Yeah, okay, yeah, so it's open. I'm not taking the top and the bottom because there is no surface to touch. So pi r square, 2 pi r square will disappear. Now I got the surface area as 348 and I need length. So if I want to find the length, length is equal area divided by pi r. Now to find the length, I need to put the value. So length equal, the area is 348. 0.7. I rounded it off. Pi is a pi, 3.14. Use a correct value. And the radius was, if I go to the very start, 75 millimeter. We do not, that was a diameter. So we do not want in millimeter. We want in meters. So if the diameter is 75, the radius is 37.5. And this one, I need to convert this one into meters. It looks like it's going to be a very long heat exchanger. So I will put the values in and I will get an answer. Okay, the surface area of the cylinder, there should be a 2 there because the formula is 2 pi r square plus a 2 pi rl. So this one disappear because I'm not taking the top and the bottom. So there should be a 2 there, which mean the 2 will come here, which mean the 2 will come here. And if we put the values, we will get an answer. Yes. So the length will be 1479 meters. So it's nearly 1.5 kilometers. So the value of the heat exchanger, we got nearly 1.5 kilometers of the tube, which mean it's going to be something like that. So this is the length of the hot one, and on the top I got the cold one, and they are parallel flow. The flow is in the same direction. So this is going to be the inlet, this is going to be the outlet. Hence we have the length, a very big length. So it's going to look like that.